Good day everyone, I am Brendale M. Susas and today we will solve problem concerning the effect of groundwater table in the bearing capacity of soil. So you have your problem, a foundation number 1, strip number 2, square in shape, 2 meters by 2 meters carries a low density of 400 kilopascal at a depth of 1.2 meters in sand. The soil supporting the foundation has a friction angle equal to 35 degrees and C prime is equal to 0. The saturated unit weight of sand is 19.5 kN per cubic meter and the bulk unit weight is 16.8 kN per cubic meter. We have to determine the factor of safety with respect to the shear failure for the following cases of location of water table. Bearing capacity factors are NQ is equal to 41.44, NY is equal to 45.41. Use Terzaghi's theory. So for letter A, water table is 1.2 meters below ground level. And for letter B, water table is 0.5 meters below ground level. So first, let us locate this water table. So for letter A, that's 1.2, so it's just equal to the depth of the sand or the foundation sa sand. So that's 1.2. And for letter B naman, yung water table natin is nandito 0.5 from the ground. So say here. So nandito. That is 0.5 meters. So then yung isa dito siya. So nandito. Locate ko na lang yan. This is 1.2. So as we can observe for letter A, that is equal to the depth of the foundation, so it will fall to our case 2. So case 2 ito. And sa case 2 natin, so for case 2 is that we will solve the Q here. Q here is equal to gamma times TF. And we will substitute this value dito. And also, we have to calculate for the gamma prime. Since sa case 2, i-substitute din natin, i-replace natin ito by gamma prime. So, yung formula ng gamma prime natin is ito. Ayun, na-solve ko na pala. So, that's, gamma prime is equal to gamma sat minus gamma of water. That's 19.5 minus 9.81. That's 9.69 kN per cubic meter. So, okay na tayo dyan. So, Q na lang dito. I-solve natin yung Q. So, Q is equal to bulk unit weight natin 16.18 times df 1.2, and that will give us a value of 20.16 kilopascal. And then we will now, since we have the value of gamma prime, so that ka naman yan, gamma prime is equal to 9.69. So, replace natin yan dito. So, substitute natin yan sa equation natin. That's QU. C prime natin is 0. NC natin wala. Pero, since 0 naman ito, so automatic 0 na yan. Plus, Q natin. So, ito na yung Q. Magiging value ng Q natin. That's 20.16. Times nung NQ natin sa given. That is 41.44. Plus 1/2 of dito, yung gamma natin dyan is replace natin ito ng gamma prime natin. So, we have that's 9.69 and base natin dito, yung base pala natin. Base dyan is that is 2 meters. 2 meters yan. So, this is 2. Times nung NY natin sa given, that's 45.41. So, QU natin dyan, that is equal to So, 1275.453 kilopascal. So now, since meron na tayong QU, so ma-solve na natin yung inaanap ng problem na factor of safety. So we have formula for factor of safety, that's Fs, that is equal to QU over ng Q allowable. And yung definition ng Q allowable, by the way, is that yung load distributed over all over the span of the footing. So since naka kilopascal ito, kilonewton per square meter, so assuming that it was already distributed all over the span, so that would be our Q allowable na. So substitute natin yan. Alright, so QU is 1275.453 kilopascal all over. Q allowable natin, that's 400 kilopascal. And Fs is equal to 3.189. So ito yung magiging sagot natin for this problem, for the letter A of this, number 1 letter A of this problem. This is our answer. And for letter B, we have water table is at 0.5 below the ground level. So here, as we can see here in our illustration, so itong distance na dito na iwan is, this is called the distance D, ito dito from here to here, and that is equal to 1.2 minus 0.5, that is 0.7 meters. So since yung sa letter B natin is siya, nandun siya sa taas ng base ng foundation, yung water table natin dito. So magiging dyan is, approach dyan is doon sa case 1. Case 1 ang magiging approach niyan. Then for case 1 is we have to still change the value of Q sa second term natin dito, and also nung sa gamma nung sa third term natin, change natin ang gamma prime. So let's first solve for this falls for case 1, and solve natin dito. We have Q. Sa case 1, different approach na, sa different equation na yung Q natin, and that equation is gamma dF minus T plus gamma prime times. So since na-solve naman natin itong gamma prime is 9.69, so meron na din tayong dinallocate na ito, then dF meron na given sa illustration natin. So masolve natin itong Q. So Q is equal to bulk unit weight natin na 16.8 times dF, that's 1.2, minus D na 0.7 plus gamma prime na 9.69 times 0.7. That will give us a value of 16 point 16.8, 0.5, 7.69.7, that's 15.183, and this is kilo. Yan, so ang next natin is isosolve yung QU. So for our QU, still same lang dito, same formula lang dito kasi for strip lang din naman ito, di ba? So QU natin is C prime that's 0 times NC, so automatic 0, plus 20.16 times 41.44 plus 1 half of gamma prime natin is 9.69 times base na to times NF na 45.41. Okay, so mali pala ito dito, mali yung input ko. So dito na change na pala, no. So na change na ito, dapat 15 point ano na ito, 183. Kasi ito na yung Q niya kasi iba na yung case niya. So Q yun natin dyan is equal to 1069.206. So solve for Fs. So the Fs is equal to Qu over Q allowable. That is equal to then Qu natin dyan is 1069.206 kilopascal over Q allowable natin na 400 kilopascal. So Fs is that is 2.673. So ito yung magiging sagot natin. It's 2.67. So okay na tayo sa strip. So for different shape naman, for square. So first is for steel, letter A natin is water table is 1.2. Is at 1.2 meters below ground level. So still same procedure lang. So this falls under case 2. Ayan. So Q natin dyan is equal to bulk unit weight na 16.18 times DF. Q is equal to gamma DF. So DF natin is 1.2. Same lang, no? Same lang. So this is 20.16 kilo pascal. Gamma prime natin dyan is 6.69 pa rin. 9.69 pala. 9.69 kilonewton per cubic meter. Kilonewton per cubic meter. Same lang. Dito na siya magdi-differ sa QU natin. So Q ang ultimate natin dyan is ito magiging ano ito 1.3 nung ito C prime natin na 0 times NC. So automatic 0 na yan. Plus Q natin is 20.16. Ito. Then NQ natin is 41.44. Plus dito siya mag-differ also 0.4, di ba kanina wala siyang 0.4. So ito 0.4 times gamma. Itong gamma change pa natin into gamma prime. So we have 9.69 times nung base na to times NY na 45.41. So ang mabibigay niya na value ay so that is 1187.449 kilopascal. And we can now solve our Fs. So same formula lang, Q over Q allowable is equal to Q natin dyan is 1187.449 kilopascal over 400 kilopascal. So Fs is equal to 2.969. So ito na. So ano lang, just for clarity. So ang mag-change lang talaga dito is mag-depend lang talaga ito sa shape kasi doon na magde-depend yung equation niya sa shape at tong sa location ng water table. So for letter B, water table is at 0.5 below ground level. So, ano pa rin ito? Case 1. Ayan. So, Q, still, same formula dito. So, copy ko na lang ito kasi same lang man, same lang 1.2, so same lang talaga. So, Q natin yan is 15.183 kilopascal. That's 0 times 1.3 nung NC, so 0 automatic, plus 15.183 times 41.44 plus 0.4 times 9.69 times base na 2 times NY na 45.41. So it will give us a value of 981.202. So now we can solve for the factor of safety. That's Fs is equal to Q U over Q allowable. So 981.202 over 400, that will give us the factor of safety na 2.453. So I hope na klaro ako sa sa solution na ito. So that would be all guys. Thank you everyone. Bye bye.